Welcome back to The Clean Truth by Roobi.
It's great to be back, diving into this.
Yeah, so today we are jumping right into our 35th deep dive. And this one is titled Iced Coffee Season, Why Your Machine Needs More Care in Summer.
Right, because, I mean, when the weather turns warm, our whole routine just completely transforms, doesn't it?
Oh, absolutely. Like you go from brewing, maybe one mindful hot cup in the morning to...
Just trying to keep this steady, massive supply of iced coffee chilling in the fridge at all times.
Exactly. It's like we basically set up a small-scale cold beverage production line right on the kitchen counter.
Yeah, and while having a chilled pitcher ready to go is, incredibly refreshing for you, this sudden spike in usage puts an unseen, a tremendous amount of stress on your equipment.
Right. We're taking a machine that was built for, essentially a morning sprint, and we're forcing it to run a daily marathon.
Which is a perfect way to put it, honestly.
I like to think about it like taking a cross-country road trip in the dead of July. If you drive thousands of miles with the car's AC on absolute blast...
The engine is just going to work overtime.
Right.
Yeah.
And if you ignore the maintenance lights blinking on the dashboard, you are going to end up broken down on the shoulder of the highway.
Nobody wants that.
No. And your coffee maker in the summer is, it's basically that car. So today's mission is to explain the hidden toll this increased brewing frequency takes on your machine.
And, of course, why regular maintenance is literally the only way to save your machine.
Yeah, and to keep your morning cup from tasting like old gym socks,
Yeah.
which is definitely a risk.
A very real risk, yeah. But the wear and tear, it isn't just a matter of mechanical parts moving more often. The real, invisible enemy here actually comes down to the geology of your local environment.
Wait, really? Geology?
Yeah, I mean, every time you fill that water reservoir, you are pulling from the natural landscape around you.
Okay, so we are dealing with geography and earth science now, not just like kitchen appliances. I imagine this has to do with tap water not just being, pure H2O.
Far from it, yeah. Most of the tap water in the United States, and really in many places globally, is what we call hard water.
Right, I've heard that term.
So it's drawn from lakes, rivers, underground aquifers, and before that water even reaches your tap, it starts as rainwater, which is naturally slightly acidic.
Oh, interesting.
Yeah, so as it percolates down through the soil and rock, particularly things like limestone and chalk, it acts like a solvent. It literally dissolves and absorbs massive amounts of the earth, specifically calcium and magnesium.
Wow. So when you put it that way, filling up the coffee maker is essentially pouring in a microscopic rock soup.
That is exactly what it is, a microscopic rock soup.
And I suppose depending on where you live, that soup can be much thicker, right?
Absolutely.
Like someone living in the Midwest or the Southwest where there's a lot of limestone in the ground, they're dealing with significantly harder water than, say, someone in the Pacific Northwest.
Right, because in the Pacific Northwest, the water might flow over harder granite, which just doesn't dissolve as easily.
Got it. So that geographic difference plays a huge role in how fast your machine degrades.
It does. But, no matter where you live, you are still introducing these dissolved minerals into a highly sensitive environment.
Which brings us to the specific mechanics of a coffee brewer, right?
Yeah.
Because it essentially takes this mineral-rich water and puts it through a rapid thermodynamic shift.
Exactly. The flash heating mechanism.
Right, because to get water from the tank on the back up to the spray head hovering over the coffee grounds, the machine pulls a small quantity of water into an internal metal tube.
And then it flash heats it to near boiling.
Yeah, and that rapid expansion from the sudden heat is what pushes the water up and out.
But during that flash heating process, some of the water inevitably undergoes a phase change. It flashes into steam.
Okay, and when water turns to vapor?
It leaves all of its dissolved solutes behind. Those heavy calcium and magnesium minerals, they just don't evaporate.
They drop out of the liquid,
Automatically.
and then they physically bond to the internal walls of the heating tube.
Huh.
So we were essentially calcifying the machine from the inside out.
Yeah, you're baking a crust right onto the plumbing.
Wow.
And this crust is known as scale, which is primarily calcium carbonate.
Okay.
It's this hard, chalky, white substance. And because summer iced coffee demands mean you're, running the machine twice or 3 times as often.
The crystallization process accelerates dramatically.
Right. Within weeks. Honestly, you can develop a significant layer of scale.
Which, that wouldn't be a huge deal if it were just a cosmetic issue hidden inside a tube.
Yeah,
right?
sure.
But scale is an incredibly effective thermal insulator.
It is. It creates a literal physical barrier between the heating element and the water.
Oh, man.
So as this crust thickens, the thermal transfer efficiency of the boiler just plummets.
All right.
The internal element has to work much harder. It stays on longer. It gets much hotter just to force enough heat through that chalky wall to bring the water up to brewing temperature.
That sounds like a fast track to burning out the heating coil entirely.
It absolutely is. But even before the machine completely dies, the water that's actually making it to the coffee grounds might not be hot enough to extract the flavor properly.
Even though the machine itself is dangerously overheating?
Exactly. The extraction temperature drops, which heavily impacts the brew quality.
That's wild.
But the problem compounds, right? Because scale doesn't just stay neatly inside the heating tube.
Of course not.
As the crust thickens, the sheer force of the boiling water breaks off tiny flakes of this calcium carbonate.
Oh, gross.
Yeah, and these flakes travel up the plumbing and lodge themselves directly into the spray head.
The spray head.
Yeah.
Which is designed like a shower head, right? With all those tiny, precise holes to evenly soak the coffee.
Exactly.
So if those holes get clogged with literal rocks, the machine just starts to suffocate.
It really does.
I think I've actually heard that sound. It's a terrible, spluttering, choking, hissing noise.
Yeah, that's the death rattle of a coffee maker. It's spitting out steam instead of a smooth flow of water.
Okay, so when you hear that sputtering, the physical blockade is severely altering the physics of the brew.
Precisely.
But here is where I kind of want to challenge the premise a bit, or at least, voice a common point of confusion I see a lot.
Sure, go ahead.
If this buildup is just natural calcium and magnesium from our local rivers, I mean, the same exact stuff that's in expensive bottled mineral water, why does it make the coffee taste so distinctly awful?
That's a great question.
Because mineral water tastes fine. So is it the minerals themselves turning the coffee bitter, or is it like a mechanical failure?
It's the mechanics. The minerals themselves are relatively neutral in terms of contributing negative flavors to the cup.
Okay.
The degradation in taste is almost entirely a mechanical failure causing uneven extraction.
Uneven extraction.
Right. Because to pull the right balance of sweet, complex flavors from coffee, you need all the grounds in the filter basket to get wet at the exact same time.
With a uniform volume of water.
Exactly. That is the entire point of the showerhead design we just talked about.
Right.
But when half of those holes are choked by scale flakes, the machine is still trying to push the same volume of water through the plumbing.
Oh, I see.
So it forces all that water through the remaining unblocked holes at a significantly higher pressure.
Ah. So instead of a gentle, even rain over the coffee bed, you get a localized high-pressure fire hose.
That's exactly what happens, and that fire hose blasts a deep channel straight through one specific side of the coffee grounds.
Because the physics of water dictates that it will always take the path of least resistance.
Right. All the water rushes through that single channel.
Wow.
And the coffee grounds trapped in that channel are relentlessly pounded by hot water.
Which just drastically over-extracts them.
Yes, and that pulls out all the harsh, dry, astringent tannins and bitter compounds that you normally want to leave behind in the bean.
Yikes. Meanwhile, the rest of the coffee bed, the part not getting hit by the fire hose, is barely getting wet at all.
Exactly. It remains under-extracted, which leaves you with weak, sour, highly acidic flavors.
So your final pot of iced coffee is this chaotic, muddy blend of sour and bitter, completely missing the sweet spot.
Yeah, so it's not the natural minerals ruining the taste. The scale is physically destroying the extraction dynamics.
Got it.
That means a proactive maintenance routine is just non-negotiable if you want good coffee.
Well, and since this scale is baking onto the hidden internal boiler, we obviously can't just reach in there with a scrub brush.
No, definitely not.
Have to dissolve it chemically. And this is where relying on a targeted, purpose-built descaler like Roobi's coffee descaler becomes absolutely vital, especially during periods of frequent summer use.
Right.
It provides the exact chemical tool needed to safely strip out that calcium crust without, destroying the appliance in the process.
Exactly. And when you look at the professional maintenance protocols, the approach is very methodical.
Walk us through it.
Well, it starts on the outside. Before tackling the internal plumbing, you want to address the exterior, particularly the hot plate, using just a simple microfiber cloth.
Right, because during those rushed summer mornings making multiple batches, splashing coffee on the hot plate is basically inevitable.
Oh, yeah.
And if you don't wipe those drops up, they bake on. You get a Maillard reaction right on the heating element, and suddenly your whole kitchen smells like stale, burnt smoke every time you brew.
It's the worst. But yeah, once the exterior is clean, you move to the internal chemistry.
Okay.
This involves taking a descaling powder, like the one from Roobi, and dissolving it into about 32 ounces of water.
And there's a trick to this, right?
Yes. The crucial detail here is that this mixing must happen in a separate vessel, like a large measuring cup, and the water must be warm.
Okay, this feels like the most common trap people fall into. They just dump the raw powder straight into the water reservoir on the back of the machine.
They do, and it's a huge mistake.
It's like mixing a cocktail directly in a delicate serving glass instead of using a shaker first.
That is a great way to think about it.
If you pour undissolved powder into the machine's tank, you are literally dropping tiny boulders into the exact narrow plumbing you are trying to unclog. You're causing the clogs you're trying to prevent.
The cocktail shaker analogy captures the mechanical risk perfectly. You have to ensure the solute is fully integrated into the solvent before it ever enters the machine's ecosystem.
Right.
And the temperature of the water used for mixing, that's a critical safety warning too. Cold water lacks the kinetic energy to dissolve the powder completely.
So it leaves you with that gritty clump problem.
Exactly.
But on the flip side, using hot or boiling water from a kettle, to dissolve the powder faster, that sounds like a terrible idea for the machine's internal heat sensors.
Oh, it is catastrophic for the machine.
Yeah.
Coffee makers are calibrated to receive water at room temperature. When the internal heating element clicks on, it applies enough heat to take, say, 70-degree water up to roughly 200 degrees.
Wow.
So if you feed it water that is already boiling, the boiler will radically overshoot its temperature parameters.
Oh, I see.
You're potentially warping the internal metal components or even tripping an unresettable thermal fuse.
Meaning the machine is just permanently dead.
Pretty much. So warm tap water is the only safe medium.
So warm water in a separate cup, stir until it is completely clear, and then pour that solution into the reservoir.
Exactly. And at that point, you just run a standard brewing cycle.
Simple enough.
As the Roobi descaler passes through the flash heating tube and the clogged spray head, the active ingredients chemically react with the calcium carbonate.
Breaking that hard crust down.
Right, into a liquid state or into soft, detached flakes.
Which is really cool because if you were brewing directly into a glass carafe, you can actually watch this happen.
Yeah.
Seeing those white flakes of dead scale floating in the water is deeply satisfying. It's visual confirmation that you've just saved your machine's life.
It really is. And after that cycle finishes, the final phase is flushing.
Right, you don't want to drink that stuff.
No, definitely not. You discard that descaling liquid and run at least 2, preferably 3 full cycles with plain fresh water.
Just to neutralize everything.
Exactly. It pushes out any residual chemical descaler and any lingering stale fragments, ensuring a completely clean slate for your coffee.
Perfect. And that flushing phase brings us to a massive myth that we absolutely need to dismantle today.
Oh, the vinegar thing.
Yes, the internet is just full of advice telling people to just buy a gallon of white household vinegar, pour it into the reservoir, and call it a day.
It's such a pervasive misconception, and it stems from just a partial understanding of chemistry.
How so?
Well, vinegar is a weak acid, specifically acetic acid, and it does have the ability to slowly react with calcium carbonate.
Okay, so it sort of works.
Technically, yes. However, acetic acid is highly aggressive towards certain metals, particularly the aluminum and copper that are commonly used in coffee machine boilers.
So we are essentially introducing a corrosive agent into a heated, pressurized metal tube. That sounds awful.
It is. When acetic acid sits inside a metal boiler, especially under heat, it initiates a chemical reaction that pits and corrodes the metal walls.
Wow.
It physically eats away at the integrity of the machine.
And if the boiler walls are being dissolved, those metal ions have to go somewhere. They don't just vanish into thin air.
Exactly. They leach directly into the water path.
Yikes.
You can end up creating compounds like aluminum acetate or cupric acetate, which then wash right into your morning coffee.
This is horrifying.
It gets worse. Beyond the mechanical damage and the trace metals, acetic acid has a very low sensory threshold.
Meaning humans are incredibly sensitive to the smell and taste of it.
Right, and it embeds itself into the internal rubber gaskets and the silicone tubing of the machine.
Oh, no. So you can't get rid of it.
The lingering, pungent odor of vinegar is notoriously difficult to flush out. It can sometimes take dozens of water cycles to fully clear.
So you literally risk turning your expensive summer coffee beans into a vinaigrette salad dressing.
Basically, yeah. Relying on a properly formulated commercial descaler avoids these chemical pitfalls entirely.
Okay, so we've handled the scale,
Hmm.
the internal rocks. But here's an area that genuinely caught me off guard when reviewing the research for this deep dive.
The cleaning part.
Yeah, there's a massive operational difference between descaling a machine and cleaning a machine. They're two entirely separate battles.
They really are. They target completely different chemical compounds.
Explain that for us.
So descaling removes inorganic mineral buildup, the calcium and magnesium from the water hidden inside the plumbing.
Right.
Cleaning removes organic matter, specifically the coffee oils and organic lipids that build up on the external food-touching surfaces like the carafe and the filter basket.
Okay, let's dive into the organic chemistry of the coffee bean itself then, because coffee isn't just dry brown dust. It's an agricultural product, a seed.
Yes.
And like most seeds, it is packed with fats and lipids.
Exactly. During the roasting process, the cellular structure of the bean breaks down, and those natural oils are forced to the surface. Okay.
When you run hot water over those ground beans, it emulsifies some of those oils and carries them directly into your carafe.
Makes sense.
And over time, these lipids coat the inside of the vessel.
I can see how this becomes a major issue for people using high-end machines with, stainless steel thermal carafes. We tend to think of stainless steel as a perfectly smooth, sterile metal.
Well, to the naked eye, it appears smooth.
But it's not.
No. On a microscopic level, stainless steel has a jagged, porous topography compared to something like tempered glass.
Interesting.
Those microscopic crevices act as a perfect anchor for organic coffee oils.
Yeah.
The lipids cling tenaciously to the metal walls.
And because these are natural organic fats, leaving them exposed to oxygen and room temperature leads to a very predictable outcome. They oxidize.
Yes, they do.
Just like leaving a stick of butter on the counter for a month, these coffee oils literally go rancid.
That's a perfect comparison. The lipid molecules break down into foul-smelling aldehydes.
Yeah. This oxidation is the primary culprit. When your beautifully brewed iced coffee suddenly starts tasting stale, old, and distinctly musty, you are effectively brewing fresh coffee and then letting it wash over a microscopic layer of rotting grease.
That is such a gross image. And to make matters worse, chemistry tells us that like attracts like.
Right.
Coffee oils are chemically drawn to other coffee oils. So a dirty carafe actually accelerates the buildup of even more grime.
Exponentially. The sticky, polymerized layer of rancid oil acts as a magnet for the fresh oils in your new brew.
So it's compounding.
Yes. It builds a thicker, more stubborn layer of musty residue with every single batch of iced coffee you make.
Okay, so breaking that compounding cycle of rancid grease obviously requires a completely different approach than dissolving minerals.
Very different, yeah.
And again, pantry staples fall woefully short here. Some people try to scour away baked-on coffee oils with a sprinkle of baking soda.
I've seen that too.
That is wild to me. It's like trying to wash a cast-iron skillet after frying bacon using only cold water and a dash of baking soda and just hoping for a clean pan.
It's just not going to work. Baking soda is a mild abrasive and a very weak alkaline base. It usually sits around an 8 on the pH scale.
Okay.
It simply lacks the chemical strength to break the heavy lipid bonds of polymerized baked-on coffee oils.
So what do you need instead?
To saponify, or essentially turn those fats into water-soluble soap, you need a specialized coffee equipment cleaning detergent, one that is formulated with powerful surfactants and a higher alkalinity to specifically target these stubborn organic compounds.
And the application method is completely different too, right?
Yeah.
You place this specialized detergent powder directly into the empty carafe.
Yes.
Not the water tank, the carafe itself. And then you hit it with boiling water from a kettle.
Exactly. The distinction of where the boiling water goes is vital.
Because we just said never to use boiling water.
Right. You never put boiling water into the machine's delicate internal reservoir, as we established earlier. But the carafe, whether it is thermal, stainless steel, or thick glass, is structurally designed to hold near boiling liquids.
Oh, that makes total sense.
When cleaning manually outside of the machine's internal system, high heat acts as a powerful catalyst. It activates the detergent surfactants and literally melts the hardened lipids, vastly improving the cleaning power.
Okay, so the detergent goes into the carafe, you fill it to the brim with boiling water, and then you just let the chemistry do the work.
You let it steep.
For how long?
If you can leave it for an hour, the chemical reaction will break the lipid bonds completely, lifting the rancid oil off the microscopic metal ridges so you can effortlessly rinse it down the sink.
Nice. And what if I'm impatient?
If you are in a rush to get a new batch of iced coffee chilling, a 20-minute steep will soften the grime enough that a quick wipe with a sponge will remove it.
Now, what about the other parts of the brewing ecosystem, like the plastic filter basket or the intricate plastic lids on the thermal carafe? Do those require the same boiling water treatment?
No, they require the same specialized detergent, but a much gentler thermal approach.
Okay.
Complex plastic lids often contain internal valves, springs, or heat-sensitive seals that can warp or trap liquid if submerged in a boiling chemical bath.
Oh, right. You don't want detergent permanently trapped inside the lid.
Exactly. Furthermore, plastic is inherently highly porous. It absorbs those rancid oils far more deeply than glass or metal.
So a regular scrub with hot tap water and a soft sponge is the safer play for the plastics.
Yeah.
It prevents those deep pores from permanently trapping stale flavors without, actually melting the components.
Spot on. Regular, proactive attention to both the hidden internal geology and the visible external organic chemistry is literally the only way to maintain the integrity of your brew.
This entire deep dive really recontextualizes what it means to hit the brew button on a hot July afternoon.
It's a lot more complex than people think.
It really is. Your daily iced coffee ritual isn't just a simple morning task. It is a heavy manufacturing process taking place right on your kitchen counter.
Truly.
Every single day, your machine is fighting a two-front war. On the inside, it is battling hard water, fighting to prevent local river minerals from scaling its internal organs and choking its heat efficiency.
And on the outside.
On the outside, it is fending off rancid, polymerized organic oils that just want to coat its surfaces and ruin the flavor of the bean.
Which is why, by dedicating just a little bit of time to this, maybe once a month during these high-volume summer months, running a proper descaling protocol for the inside and a dedicated detergent cleaning for the carafe.
You are rescuing your machine from an early grave.
Exactly. And just as importantly, you are saving your own taste buds from the taint of musty old grease.
Absolutely. So, as a final thought to mull over, I want you to consider this. Your morning cup of coffee is essentially a daily, invisible battle between the local geology of your municipal water supply and the organic chemistry of the coffee bean itself.
That's a great way to look at it.
If you want to see exactly what your machine is up against, look up your local city's water quality report online and check the hardness levels.
Oh, that's a brilliant idea.
It is genuinely eye-opening to see just how much rock you are pushing through that delicate plumbing. By keeping your equipment perfectly clean and free of scale, you are leveling the playing field, ensuring the bean wins that battle against the rocks every single time.
Couldn't have said it better.
So the next time you hear that machine sputter, you won't just wonder what's wrong. You'll know exactly how to fix it. Let's explore why your coffee machine works harder during summer and how regular maintenance keeps every cup tasting its best.